Today we're going to look at simplifying radicals. A radical is just another name for a square root. The square root of 4 is read radical 4 sometimes. And we're going to look at simplifying these radicals. And when we simplify a radical, we break down the number into prime numbers. I'm going to show you what that looks like in just a moment. But a prime number is a number that is only divisible by 1 and that number. It has no other factors. So if you have two of a kind or two terms that are alike, then that term comes out of the radical. And I want to show you an example of a perfect squared number here. And we have a square root of 25. Square root of 25, we can break 25 down into 5 times 5. Okay? So when I have two that are just alike, this term, 5, comes out of the radical. The square root of 25 is 5. I had no leftover terms. Everything comes out. Okay? Now, you should know your perfect squared numbers up to this point. If you know your times tables to 10, even to 12, you should know what those are. So I want to just kind of look at those for just a moment. And we're just going to kind of run through a couple of them. So 4 would be 2 times 2, right? So therefore, the square root of 4 is 2. And notice I have two 2's, so the 2 comes out. The square root of 9 is 3 times 3, so the square root of 9 is 3. The square root of 16 can be written as 4 times 4, so since I have two 4's, that 4 comes out and the square root of 16 is 4. Now, in the definition when I said simplify, I said simplify down to prime numbers. Sometimes that's not necessary if you know what a perfect squared would be. So 36 would be 6 times 6, so you already have a pair. 49 would be 7 times 7, so square root of 49 is 7, and so forth, okay? So perfect squares, you probably even know up to 12. So the square root of 144 is actually 12 times 12. So 12 would be the square root of 144. Now sometimes they give you fractions. Don't let that mix you up. Notice here we have a square root of 4. And remember, with 4 was 2 times 2. And then the square root is still on the 9. So the square root of 9 was 3 times 3. So 2 is in my top, 3 is in the bottom of that fraction. Now once I take the square root and the number comes out of the radical, if there's nothing left in the radical's gone. Okay? The square root of 1 is 1 times 1. And the square root of 16 is 4 times 4. So the square root of 1 over 16 is 1 over 4. Okay? 25 would be 5 times 5. We said that earlier. And then 81 is 9 times 9. So the square root of 25 over 81 is 5 over 9. Now, those were perfect squared numbers. Most of what you get probably won't be perfect squared numbers. So we want to know, what do I do if I don't have two of kind? What happens to that number? Okay? So we're going to look at some non-perfect squared roots, and we're going to simplify them. Okay? So we want to break these down. And 24, if I'm just thinking, I'm going to say 4 times 6. Okay? Now, 4 is a perfect squared number. Remember, it's 2 times 2. So this 2 can come out of the radical. All right? Now 6 is 2 times 3. Those are not alike, so I don't have two of a kind here. So this 6, because it didn't simplify out, stays in the radical. Okay? So let's just make sure we're clear about this. I broke 24 down into 4 times 6. 4 is a perfect squared number. Square root of 4 is 2. so 2 came out. 6 is 2 times 3, so it's not a perfect squared number. It stays in. Okay? So let's try another one. 90 would be 9 times 10. 9 is a perfect squared number. Remember, it's 3 times 3. So this comes out. 10 is not a perfect squared number. It's 2 times 5. So that 10 has to stay inside the radical because it doesn't have a perfect square to be removed. All right, now there's a bigger number up here, 72. So let's think. 2 will go into 72. All right, 2 goes into 7 3 times with 1 left over, and 2 goes into 12 6 times. Now 36 is a perfect squared number. Remember, it's 6 times 6. So since 36 is a perfect squared number, that 6 comes out. 2 is not a perfect squared number. It has to stay in. Okay? All right, pause the video and you try these next few, if I can get the screen to move. You try these next few and let's see if you can simplify it. Pause it and then come up with your factors. All right, so let's look at 63. Now, if you know your times tables, 9 times 7 is 63. 9 is a perfect squared number. It's 3 times 3. So 3 can come out, but 7 is not a perfect squared number. It stays in. Okay? Now, let's try this next one. It's a pretty big number. And right off the bat, I can't think of a perfect squared number that will go into it. So we're going to break it up like this. 45 times 10. Does that make sense? Okay. Now 45 is 9 times 5. 9 is a perfect squared number. Remember, it's 3 times 3. So I know a 3 is going to come out. Now I have this 5 sitting here and I have a 10. Well, 10 is 5 times 2. So look what I have. I have another perfect squared term here because there's 2 5s. And because I have 2 of a kind, it can come out of the radical. So along with this 3, the 5 comes out of the radical. Now 2 doesn't have a pair. It has to stay in the radical. Okay? Now look outside. I had a 3 and a 5 that I could get out of the radical. When I bring them out, I have to multiply those back together. So 3 times 5 is 15 and the square root of 2. Okay? So remember, you're looking for 2 of a kind. When you have 2 of a kind, that term comes out. All right, let's try another one. This one's 216. Right off the bat, I can't think of anything that's a perfect square that will go into it. But I do realize that probably 3 goes into it. Because there's 21, 3 goes into 21, and 6, and 3 goes into 6. So I'm going to break this down into 3 times something. 3 goes into 21, 7 with nothing left over, and 3 goes into 6 2 times. All right? 72. It goes in, divides by 2. 2 goes into 7 3 times with 1 left over, and 2 goes into 12 6 times. Now 36, I know that's a perfect squared number, so I know I can get a 6 out. Now this 3 and this 2 do not have a pair. They don't have 2 of a kind. These are individual terms that don't match up. Both of those numbers, the 3 and the 2, have to stay inside the radical. And we're going to multiply them back together. 3 times this 2 gives us a 6 on the inside. Okay? Now I want to do one more. If you want to pause the video so you can try it, that'd be great. We're going to try this number. Square root of 343. Now this one's a tough one because 3 doesn't go into all of that. Let's think of something else. Let's get our calculator. Say, okay, I know 5 doesn't go into it because it doesn't end in a 5 or 0. And I know 2 doesn't go into it because it's not an even number. 10 doesn't divide into it because it doesn't end in 0. So let's try some other numbers. Now 2, 4, 6, and 8 would be out because they need to be even numbers. So let's try some odd numbers. 3, we said it did not go. 5, we said it did not go. But let's try 343 divided by 7. 7 does divide into 343 because 7 times 49 is 343. Now, as before, we saw that 49 was a perfect squared number. 7 times 7 is 49. So a 7 can come out. There were 2 of them in there. There happens to be a third 7 in there. But it doesn't have a pair. It doesn't have one to match up with like this one did. So that 7 is going to have to stay in the radical. So the square root of 343 is 7 square root of 7. Okay?